sum from I equals 1 to n of b minus a over n times f of a plus I times b minus a over n. Oh, I forgot to tell you one thing. They invented a symbol for this, so that you don't have to keep writing this over and over and over. They wanted you to have a symbol for this. Just a nice, concise little symbol. So they write this. And remember, the book thinks that you have no idea that that has anything to do with an antiderivative. Okay? But maybe it doesn't. Maybe I lied to you. Let's find the true area under the curve here. So this is the limit as n goes to infinity. The sum from I equals 1 to n. What's b in this case? 2 minus, what's a? Negative 1 over n times f of, what did you say a was? Minus 1 plus I times, b minus a is 3, isn't it? Right, 2 minus a minus 1 is 3. So this is the limit, as n goes to infinity, of the sum from I equals 1 to n of 3 over n times. Well, how would you plug that into f? Suppose I ask you to plug this into f of x. How would you do that?
You put it in x.
Well, what if I asked you, remember, here's y equals f of x, and f of x is 1 plus x squared. So suppose that I tell you that x is 1. How would you plug that into f? And what would I write? 1 plus 1 squared equals, who cares? What if I asked you to plug 2 into f? What would you write? 1 plus 2 squared equals, who cares? What if I asked you to plug I into that? What would you get? 1 plus I squared. What if I asked you to plug I plus 1 into that curve? 1 plus I plus 1 squared. What if I asked you to plug minus 1 plus 3i over n into that curve? What would you write? 1 plus 3i over n minus 1 squared, to write it in a more convenient fashion. Isn't that f of a plus I times b minus a over n? So in other words, we need to write now 3i over n squared minus 1. Oh, excuse me, 3i over n minus 1 squared plus 1. There's f of a plus I times b minus a over n. And what you're hoping on the exam is that I don't give you anything worse than a parabola. Cubic is the worst I would go. Well, let's crank that out. This is the limit as n goes to infinity of the sum from I equals 1 to n of 3 over n times. Well, when I square that out, I get 9i squared over n squared minus 6i over n plus 1 plus 1. Which we could simplify and write as limit as n goes to infinity. Are you having fun? Sum I equals 1 to n. You're going to enjoy this problem so much. I'm going to write this as 27 over n cubed I squared minus 18 over n squared times I plus 6 over n. Somebody tell me what the hell just happened.
Multiply
Oh,
this
I
out.
distributed 3 over n 3 times 9 is 27. N times n squared is n cubed, and I factored out the I squared. 3 times negative 6 minus 18, n times n is n squared, and I factored out the I. 1 plus 1 is 2. 2 times 3 over n is 6 over n. Well, you guys probably remember all the rules of summation, right, from your college algebra days. You remember what happens. I've already told you this. The sum from I equals 1 to n of I, what was that? N times n plus 1 over 2. I've already told you that the sum from I equals 1 to n of I squared is n times n plus 1 times 2n plus 1 over 6. And you may not remember, but I have already today told you that the sum from I equals 1 to n of I cubed is equal to n squared times n plus 1 squared over 4. It's just a coincidence that it's the square of that. You may have forgotten some of the other rules of summation. If I have the sum from I equals 1 to n of some constant, right? In other words, I'm adding a constant together n times, well, that's n times the constant, because after all, you're adding the constant together n times. Well, we need that now, because we're about to use these rules. This is the limit as n goes to infinity. And now I'm going to use this summation formula on this first term.